Okay, so we have our neuron, and different parts of the neuron are going to help with different parts of transmitting the action potential.
So what segment are you drawing right now?
Okay, so this is the receptive segment. And it is composed of the cell body and the dendrites.
Beautiful.
Yeah. Okay.
What
so
kind of channels are in there?
There are chemically gated sodium. Chemically gated. Sodium channels, potassium channels, and chloride channels.
Beautiful.
So when a neurotransmitter binds to one of these channels, it's either going to cause an inhibitory or excitatory response. So an EPSP, excitatory. What is the P?
Excitatory postsynaptic potential.
Okay. Or
Because that is the postsynaptic neuron.
Yep.
And the EPSP or the IPSP is the presynaptic.
so the dendrites are going to be the postsynaptic neuron because they are receiving the neurotransmitter. The presynaptic neuron are going to be the synaptic knobs that are going to, these are great synaptic knobs, connect.
To drop the neurotransmitter.
Okay, they're going to release the neurotransmitter. So there's also IPSP, which is the same thing as EPSTP, but it's inhibitory. Okay. So once the chemically gated, so in an excitatory response, once chemically gated sodium channels open due to the binding of a neurotransmitter, the sodium is going to go into the neurolemma, which is the neuron of the neuron, and it is going to take the resting membrane potential of the neuron, which is, we'll do a little thing over here, which is -70. And it is going to bring it up and depolarize it to -65.
-55.
-55.
If you were to hit -65, would that create an action potential?
Yes, because
No.
there's,
I just said -65.
oh, -65, never mind. So if it hits -65, it would not cause an action potential because it is, the -55 is
threshold.
Is the threshold.
Good.
But there's the idea of all or nothing, where if it hits -55 or anything positive or more positive than that, it is immediately going to cause an action potential. However, if it does not hit -55, which is the threshold, there will be no action potential. So excitatory would cause the neuron to get to the threshold, and inhibitory would prevent it.
Okay, and those are both, we should write that those are both graded potentials
Yes.
in the
These
receptive
guys?
segment, yeah. both graded potentials, so they are weak, or
put it over here. So they are both graded potentials.
and if you have enough E EPSPs,
Then, so the APSP, as it moves around the cell body to get to the, so it's going to lose excitability, what you call it? Yeah. It's gonna lose excitability as it comes to the next segment, which will be the initial segment. But a lot of times this is what Amy said, but a lot of times you will have a lot more, it'll be a lot more positive.
Right.
So that once it loses its kind of voltage excitability, it's still going to be able to hit that threshold. Okay, so this is depolarization. I'll just stop there for now. So once these are opened, we're gonna get to the initial segment. Alright. So the axon, oh wait. Yeah, I was right.
axon hillock,
Axon hillock is where
aka action potential,
action potential is going to be released. Yep.
and then what happens after that?
It is going to, we're going to draw on the myelin. It's going to send an action potential.
What kind? Voltage.
Voltage. Oh.
Because there's so much electric going in, it is a voltage change.
Yes. Okay. So, due to the change in voltage that is happening due to the excitatory graded potential, it is going to end up opening voltage-gated sodium channels. And that's going to cause a chain reaction down the axon. It's going to create a voltage of positive 30. Or is
Yes,
this- yeah,
positive 30.
positive 30. So back to this. So now we're at positive 30. So this whole thing, depolarization. Cool. So we're going to keep going down the axon and continue with this voltage of plus 30. We'll just voltage gated. Okay. Let's see. Do I start talking about the potassium?
Yeah,
Channels
so we
opening
should
too.
mention that potassium leak channels are leaking out potassium too, which helps with the positive 30.
Yes.
And
And that's in conductive segment as well?
yeah.
Okay.
And on top of that, like, it goes only in one direction because the inactivation of the gates and sodium, you have to remember that the potential wants to move one way. It can only go one
Oh,
direction
okay.
down the neuron.
Yeah, okay. So we have potassium leak channels that are going to help with keeping the voltage of positive 30.
And this is where we start to repolarize.
Yep. Okay, so once we start repolarizing, it is because we have the sodium or voltage gated sodium channels, and they are going to go into a locked position, which helps keep the action potential going in one direction, but they are going to become in a locked position and they can't open again until another action potential is sent down the axon.
Correct. So I'm gonna read this straight from the
Yes.
text. The depolarization also causes voltage-gated potassium channels to open slowly, allowing potassium to rush out and repolarize the membrane. Too much potassium goes out and the membrane is briefly repolarized, creating the -80
So it's going to, so this is repolarize,
repolarization.
and then it's going to hyperpolarize because it's let too much calcium out of the neuron. Okay, which is -85?
-80.
-80.
It might reach -85, but what they have us is -80.
Okay, cool.
Okay, and then we are then what do we use to help the cell reach resting membrane again? The -80.
The sodium potassium pump.
Right.
Okay.
And how many potassium leak out?
3 sodium go out, 2 potassium go in.
Yes, sorry.
It's okay. Okay. Okay, so 3 and A plus, oops, I did that backwards, but they'll go out and K plus or potassium will go in. And this is going to help with the bringing it back to resting membrane
The
potential.
hyperpolarization, yes.
Bring from polarization to -70 millivolts, which is our resting membrane potential.
Okay. So
Okay.
what happens when the action potential is at the synaptic knob?
So this is called the transmissive segment. And this is when the action potential is going to cause the synaptic knobs to release the neurotransmitter. So this is really similar to or the exact same as with our muscle contraction, where you have the synaptic knob. That's my synaptic knob. And here we got our either that or we'll use an actual neuron. Okay, and we'll have our dendrites and stuff. Blah, blah, blah. Yeah. And
What voltage gated channel is opened in the synaptic knob?
we have voltage gated calcium channels. And then that is going to go into the synaptic knob, and it is going to bind to vesicles.
And exocytose, the neurotransmitter.
Yep, so it's going to go exocytose, neurotransmitter, and that is going to start the whole process over again when they bind to the postsynaptic neuron from the now presynaptic neuron.
Beautiful.